All right, it should not come as a surprise to you that today we're going to talk about division properties of exponents. All right, so here we go. We've got the quotient property of powers. Yesterday we talked about the product property. Today is the quotient property. So if A is any non-zero real number and M and N are integers, then A to the M over A to the N equals A to the M minus N. So it made sense when we were multiplying that we added the exponents. Now when we're dividing, we're going to do the opposite. We're going to subtract the exponents. So let's look at some examples. I've got 2 to the 9th divided by 2 to the 7th. So I'm going to divide by subtracting my exponents. 9 minus 7, 2 to the 9 minus 7 is 2 to the 2, or 4. I have y divided by y to the 4th. So I've got y to the 1. Remember, there's no exponent there, so that is really a 1 minus 4. So I've got y to the negative 3. Remember from our work yesterday, we cannot leave a negative exponent, so I'm actually going to write that as y over 1 over y cubed. Okay? Now this one should be a pretty simple one. I've got x to the 4 minus 3, or x to the 1. Yes, in fact, you can just write x. All right, this one's going to take a couple steps because notice I've got some product properties here. So I'm going to want to simplify that first before I do my division. So I've got d to the 4th, e to the 3rd, which I'm just rewriting because remember I've got two variables being raised to a single power. So I'm going to distribute that power. So I really have d squared, e squared. Now I can take these in pieces and do the subtraction. And I've got d to the 4 minus 2 and e to the 3 minus 2. So I've got d squared e to the 1, or just plain e. And finally, I have, again, I'm going to want to distribute this first. I've got m to the 5th, n to the 4th over m to the 10th. Remember, I need to multiply these times n. So this is going to be m to the 5 minus 10, or negative 5, and n to the 4 minus 1, or 3. I cannot leave my negative exponent, so I'm going to have this still stays up on top, so I've got n cubed over m to the 5th. Remember, this just drops down below. Okay, so this seems pretty easy, hopefully. All right, so what we just did actually in the last slide, we're going to be doing here, and that is we're splitting up. We've got two variables being multiplied by each other, So in fact, we can split those up so that I'm just multiplying or dividing these two and then dividing these two, because we'll see as we're using scientific notation that we're going to want to take our first part of our scientific notation, that decimal number, and treat that separately from our power of 10. So let's take a look at an example. So we're going to do this division problem with scientific notation, and we're going to answer in scientific notation. Okay, so I would write this as 2.5 times 10 to the negative 2 divided by 5 times 10 to the 4th. So notice if I separate these out, so I do my A divided by B, this is going to be a whole lot easier because I already know how to handle these power properties. So I've got 2.5 divided by 5, so I've got 0.5, and I know that this is going to be 10 to the negative 2 minus 4, or negative 6. So I've got 0.5 times 10 to the negative 6. Now, remember, to be in scientific notation, I need a number that is at least 1 or greater than 1 and less than 10. My 0.5 is not going to work. So I'm going to have to move that decimal over one more place for it to be in correct scientific notation. So now I've got 5 times 10, and what's going to happen to my exponent? Well, here I had -6, but I'm actually even smaller because I've moved it over to a bigger number, and it really represents a smaller number. So that exponent is now going to be -7. You can prove this to yourself by writing out these numbers. 2.5 times 10 to the -2 would just be 0.025. And 5 times 10 to the 4th would be 5 and 4 zeros. And you could divide this and you will see that you get this number. Okay, so we've got another scientific notation problem to answer. In 2005, U.S. public debt was about 7.9 times 10 to the 12th dollars. The population is approximately 2.97 times 10 to the 8th. I want to know what the average debt per person is, and actually I'm going to have you write this in scientific notation, not in standard form. So I'm asked to find the debt per person. Okay, so debt per person. So I've got my debt up here, so 7.9 times 10 to the 12th, and here are my persons. My population is 2.97 times 10 to the 8th. Okay, so here I've got debt per person, and I'm going to divide by splitting these up into pieces. I have 7.9 divided by 2.97, which is 2.66. And my power of 10, 10 to the 12th minus 10 to the divided by 10 to the 8th is 10 to the 12 minus 8, or 10 to the 4th. So if you actually were to write this in standard form as it was asked in there, of course I'm going to move this over 4 decimal places. So that would be 26,600 per person of debt. And I imagine in 2014 it is a whole lot higher than that. Okay, so I've got the positive power of quotient property. So just like before, when we had a power outside of our parentheses, in effect we're going to distribute that power to everything inside the parentheses. So I'm going to distribute that exponent to both the numerator and the denominator. So a over b to the n is the same as a to the n over b to the n. So let's look at some examples. We're going to simplify this problem. That's going to be 4 cubed over 5 cubed. And these are numbers that are small enough that we should know what these are off the top of our head. That's going to be 64 over 125. If the numbers are too big, don't worry about actually finding a value for them. You leave them in exponent form. And this next one, okay, so I got a couple things going on here. I'm going to distribute that cube, that power of 3, but I've also got a power inside my parentheses. So remember, I'm going to have to distribute that to everything. So I'm going to break this up. 3x squared, all raised to the 3rd power, over yz raised to the 3rd power. So now I'm going to distribute that cubed. I've got 3 cubed x, and remember, now I'm going to have to multiply, so x to the 6th over, distributing that 3, y cubed, z cubed. And now I'm going to simplify just a little bit. I've got 3 cubed, or 27, x to the 6th over y cubed, z cubed. Okay? So it is now your turn. Pause the slide here, see if these work, and check back and see. Okay, hopefully these all made sense to you and you have the same answers that I do. moving on to the negative power of a quotient property. So remember when x to the negative n equals 1 over x to the n, okay? Well, sometimes x is going to be a fraction. So here I've got a whole fraction raised to a negative exponent. So what's going to end up happening is, in effect, my numerator and denominator are going to flip places. So I can show you how that works, and then I'm going to show you just the easiest way to do that. Okay, so what this would be is this whole fraction flip down 1 over 3/4 all raised to the third power. And of course I could distribute that. So 1 over 3 cubed, or 27, over 4 cubed, or 64. And then when I simplified this fraction, because I've got a fraction in my denominator, that's not going to work. It's going to become 64 over 27. Remember, I did the outsides and the insides. This could technically be over 1, or I am multiplying by the reciprocal. Well, notice what happened in the end was the 4 cubed ended up on the top, and the 3 cubed ended up on the bottom. So let's see if we can make it a little bit faster this time by just moving what we need to up and down. So this, of course, is going to be down in the denominator, but we're squaring everything. So I'm going to have 4a squared. And in the numerator is going to be my b squared c cubed, all of that raised to the second power. So I'm going to have b to the 4th, c to the 6th. Okay. If this made sense to you, great. This is your turn. You've got 4 problems to do here. Some of these do get complicated, so I'll try to show you lots of steps to solve them. But pause your video, please, and see if you can come up with these answers. Okay, I'm going to rejoin you right here just for a minute to go over this. Notice my y cubed flipped up, my 2x squared came down, and I still raised them to the second power. Simplified, they looked like this. Here I had 2 negative exponents, so my numerators and denominators flipped, and I still distributed the cubed to each part, and eventually I multiplied the 2 pieces to get this number. You're welcome to be using a calculator, so don't hesitate to actually do the multiplication. This time I've got a positive exponent, so don't get confused. This one's not going to flip. Down here, I've got a positive exponent and a negative exponent. So pause it again and see what you got. These are not yet simplified. I have the same variable in the numerator and in the denominator, so I can simplify this. And 51. Okay, that's fine. Okay, so these are going to be divisible by 8. So I have 8 over 81. And these 2 c's, I'm just going to end up with c to the 1, and my d is going to stay in the denominator, d to the 6th. Okay, so assuming that all of that made sense to you, you should be able to do these. That is question 4. These 7 problems. Bring these in on a piece of paper tomorrow, and we will check them in class.